We are counting down the 10 most dangerously radioactive places on Earth today. From natural hotspots where residents live with background radiation far above the global average, to zones poisoned by nuclear accidents, weapons testing, and secret dumping, these sites reveal how invisible contaminants still threaten entire landscapes. Which location ranks as the most hazardous right now? Let us begin with number 10. On the shores of Kerala in India, stretches of dark, heavy sand hold a secret. Some of the highest natural background radiation levels on any inhabited coastline are found here in Karunagapalli. Monazite-rich sands contain thorium 232, a radioactive element with a half-life measured in billions of years. Residents receive annual doses several times the global average, over 10 millisieverts per year in some beachside spots, compared to about 2.4 millisieverts worldwide. Daily life continues as normal. Fishing boats line the shore, and artisanal miners sift the sands for minerals, often unaware of the radiation beneath their feet. Decades of health studies by Indian scientists have found no dramatic increase in cancer rates, though research into subtle effects continues. Unlike disaster zones that follow industrial accidents, Karunagapalli stands as a reminder that nature itself can create invisible hazards, setting a baseline for what is considered high, yet naturally occurring radiation exposure. Along the Somali coast, the line between rumor and reality blurs. Since the early 1990s, reports have surfaced of foreign ships dumping hazardous and possibly radioactive waste in these waters, exploiting a nation left without effective government. After the 2004 Indian Ocean tsunami, villagers described barrels and containers washed ashore, some leaking unknown substances. United Nations Environment Program teams documented these findings and heard accounts of illness in nearby communities. But security risks and conflict have blocked thorough investigation. Without systematic monitoring, no one can say how much radioactive material, if any, lingers offshore or in local fisheries. The absence of data here is its own danger, a coastline where the true risks remain unmeasured and unproven hazards cannot be ruled out. Sellafield on the coast of Cumbria stands as one of the world's most complex nuclear sites. For decades, reprocessing plants here discharged radioactive effluent into the Irish Sea, most notably cesium-137 and technetium-99. By the late 20th century, scientific surveys revealed that seabed sediments near Sellafield contained some of the highest concentrations of artificial radioactivity found in any marine environment. Even as discharge limits tightened and releases fell sharply after the 1990s, the legacy remains. Hotspots of contamination persist in offshore muds, coastal salt marshes, and tidal flats. Regulatory monitoring by the UK Environment Agency and OSPAR shows that radionuclide levels in fish, shellfish, and seaweed have declined, yet traces are still measurable along the British and Irish coasts. The challenge now is not just cleaning up the site itself, but managing long-lived marine contamination, an issue that will outlast current decommissioning efforts by generations. High above the Mailu-Su River in Kyrgyzstan, steep mountain slopes cradle more than 2 million cubic meters of radioactive tailings, remnants from Soviet-era uranium mining. 23 tailings pits, some perched on unstable ground, hold the legacy of decades of ore extraction. The region sits in a seismic zone, where landslides and floods are a constant threat. In 1958, a dam failure sent hundreds of thousands of tons of waste downstream, contaminating farmland as far as the Fergana Valley. Today, international projects led by the International Atomic Energy Agency and the World Bank have stabilized the most dangerous dumps with engineered covers and reinforced riverbanks. Yet, the risk remains. A major earthquake or sudden flood could still breach the barriers and release radioactive material into the river system. Local authorities now maintain monitoring stations and emergency plans, but the valley's future depends on vigilance and the ongoing strength of these defenses. Behind the security fences of Seversk, deep in Siberia, the Siberian Chemical Combine remains one of the world's largest and most secretive nuclear complexes. Established in the early 1950s as the closed city of Tomsk 7, it produced plutonium, enriched uranium, and reprocessed spent fuel for decades. On April 6, 1993, a chemical explosion in a reprocessing plant released about 30 terabecquerels of radioactive material, mostly fission products, and a smaller quantity of plutonium, into the air and across the countryside north of the site. The plume contaminated farmland, part of the village of Georgievka, and a stretch of the Samus-Tomsk road. While no workers suffered acute injuries, decontamination teams removed soil and posted warning signs, and restrictions were placed on local food and pasture. Today, Seversk still stores millions of terabecquerels of radioactive waste, much of it injected deep underground. Independent monitoring is limited, and key details remain classified, leaving the true long-term risks open to debate. Beneath the sagebrush plains of eastern Washington, the Hanford site stores 56 million gallons of radioactive waste in 177 underground tanks, remnants from decades of plutonium production during the Cold War. Some of these tanks, especially the older single-shell designs, have leaked, sending radionuclides like technetium-99 and strontium-90 toward the groundwater. The Columbia River, a lifeline for the Pacific Northwest, flows just a few miles from the tank farms. Environmental monitoring shows technetium-99 plumes moving slowly through the subsurface, raising concern about long-term impacts on water quality and wildlife. Hanford's cleanup, governed by the tri-party agreement between the Department of Energy, EPA, and Washington State, is one of the largest and most complex environmental remediation efforts ever attempted. Engineers face the challenge of containing waste that will remain hazardous for centuries, balancing massive engineered barriers with the reality of aging infrastructure and the persistent risk of leakage. Across the vast steppe of Kazakhstan, the Semipalatinsk test site, known locally as the Polygon, bears the scars of more than 400 Soviet nuclear detonations. From 1949 to 1989, atomic and thermonuclear devices were set off above ground and below ground, leaving behind crater lakes and zones of persistent contamination. Villages like Dolon, just outside the test perimeter, received repeated doses of fallout as prevailing winds carried radioactive particles across grazing lands and homesteads. Decades of health surveys have documented higher rates of cancer and birth defects among residents, though tracing each case to a single event is nearly impossible. Even today, researchers with the Kazakh National Nuclear Center and international teams map lingering hotspots, cesium-137, strontium-90, and plutonium isotopes, especially near ground zero markers and tunnel portals. The landscape appears empty, but the legacy of dispersed fallout remains woven into the soil, the water, and the lives of those who stayed. On March 11, 2011, a massive earthquake and tsunami struck Japan's northeast coast, overwhelming the Fukushima Daiichi nuclear power plant. The loss of power and cooling triggered meltdowns in 3 reactors, hydrogen explosions, and the release of large amounts of radioactive material into the air and the Pacific Ocean. The International Atomic Energy Agency classified the disaster as INES Level 7, the highest category, matching Chernobyl. More than 1,000 square kilometers were declared evacuation zones. Today, some towns have reopened after extensive decontamination, but others remain off-limits, especially forested hillsides where cesium-134 and cesium-137 persist in soil and leaf litter. Surrounding the plant, over 1 million cubic meters of treated water are stored in hundreds of tanks. This water has been processed to remove most radionuclides, but it still contains tritium. That remaining tritium is at the center of a national debate, as TEPCO plans controlled releases into the sea. Dose maps from Japan's Nuclear Regulation Authority show many areas now under 1 millisievert per year, but localized hotspots remain. The long-term challenges of decommissioning, water management, and rebuilding public trust continue to shape daily life in Fukushima. On April 26, 1986, a sudden explosion tore open Reactor 4 at the Chernobyl nuclear power plant, sending clouds of radioactive material across Ukraine and beyond. The disaster forced the evacuation of 116,000 people in the first wave alone, leaving behind the Chernobyl exclusion zone, an area still spanning 2,600 square kilometers. Decades later, the landscape is marked by silent reminders: the skeletal remains of Pripyat, the abandoned city, and the Red Forest, where radiation turned pine trees a rusty red and killed them within days, stand as visible evidence of the catastrophe. Even now, the Red Forest is one of the most radioactive places in the zone, with local hotspots exceeding 100 microsieverts per hour, hundreds of times above typical background. To contain the reactor's remains, engineers slid the new safe confinement, a massive steel arch, over the old sarcophagus in 2016. This structure is designed to prevent further releases and to enable the eventual dismantling of the reactor ruins. Today, strict access controls and ongoing monitoring remain in place. Dose maps from Ukrainian regulators and the United Nations Scientific Committee on the Effects of Atomic Radiation show that while much of the zone has dropped to a few microsieverts per hour, concentrated danger lingers in soils, debris, and decaying vegetation. The Chernobyl exclusion zone stands as a stark example of how a single night's events can create a radioactive legacy that will shape the land for generations. Hidden in the southern Ural Mountains, the Mayak Production Association stands at the center of one of the world's most acute radiological disasters. In September 1957, a buried tank holding high-level radioactive waste exploded with the force of about 70 petabecquerels, scattering a trail of contamination known as the East Urals radioactive trace across nearly 20,000 square kilometers. Soviet authorities kept the event secret for decades, evacuating villages and posting soldiers to measure homes and cull livestock, while doctors were forbidden from mentioning radiation sickness. For years before and after, Mayak discharged radioactive waste directly into the Techa River, exposing thousands of residents downstream. Medical studies of the Techa River cohort, led by URCRM, have documented elevated rates of leukemia and solid cancers among those who drank and bathed in the contaminated waters. Lake Karachay, used as a dumping ground for the most concentrated liquid waste, became infamous in the 1960s. Standing on its shore for just an hour could deliver a lethal dose, several sieverts, making it one of the most radioactive places ever recorded. In 1967, drought exposed the lakebed, and winds carried radioactive dust over hundreds of square kilometers. Today, Karachay is capped with concrete and rock, and access is tightly restricted. Yet high-activity waste remains beneath the surface, and groundwater contamination persists. The Mayak site's legacy is a closed zone of engineered barriers and monitoring posts. But the full inventory of long-lived isotopes, strontium-90, cesium-137, and plutonium, will demand active management and vigilance for generations. Nowhere else combines such concentrated waste, proven human exposure, and decades of secrecy, placing Mayak and Lake Karachay at the top of the world's radioactive hazard scale. Across all 10 sites, one truth emerges: radioactive contamination lingers for generations, whether from human mistakes or natural geology. These places prove that the consequences of radiation outlast political eras and scientific progress. The real legacy is our responsibility to manage what we cannot erase. Thanks for watching.